Now let's look into axis scales and ticks. So each axis has two or three axes. So axis objects representing the x-axis and the y-axis. These control the scale of the axis. The tick locators and tick formatters. So basically if you want to do any modification, we can use axis A, X, I, S axis, and it consists of different methods, and using that we can do lot of customization such as tick locators and tick formatters. All that can be done using that. So additional axis can be attached to display further axis objects. Okay, let's begin with scales. So in addition to the linear scale, matplotlib supplies non-linear scales such as a log scale. Since log scales are used so much, there are also direct methods like log, semi log x, and semi log e. So there are a number of scales so that you can explore, but here we will use one log scale and check how it works. Mm, this is axis scales and ticks. That's the main section. Axis scales and ticks, and inside that we are working with scales. The first one is scales. Okay, so let's take one example here. As usual, let me check fig. X is equals to plt dot subplots, and I'm gonna give two arguments here. I'm gonna set a tuple to set the grid 1 comma 2, and then after that 1 comma 2 I'll go with the fixed size. I'm gonna give a tuple. It's 5 comma 2.7, and as usual layout is equals to constrained. That's it, and execute. Of course there is an issue. What's that? Invalid syntax maybe meant double equals to, where double equals to has come. Fig x plt dot subplots 1 comma 2 comma fixed size 5 comma 2.7, and layout is constrained. Invalid syntax may be meant. Okay, that's okay. Let me copy this the above comment. Okay, this is fine. So now let me add few more arguments to here. The first one is 1 comma 2 second one is layout. Constrained. Yeah, it's done. It's all set. So our figure is ready now. Clear? So this is our layout. Now I'm gonna add the data. X data is equals to np. An array will be taking a range of len of data 1. So this is, we'll make an ordinal for that, and we'll take data, and this time it would be y-axis. So I'm going for the 10 power of data 1. That's what. So now let's plot. So axis of, let me add axis here. I'm going to use that axis of 0. It's kind of indexing. and then plot x data. What I want to plot, x data, this x data array on x axis, and y data is on y axis. So data, and execute, and here is that the first plot has been created successfully. So now let me add a second one. For second one, axs of 1 dot set. So let me set the y scale. Okay, first let me say y scale as a log. You got the log. See, for this we got the log 10 power 0 till 10 power 1. If you want to set limit, you can set the limits also. That's fine. So now I'm going to plot the second one also. X of 1. So this is 0, x of axis of 0. This is the first plot and this is the second plot. That's what the indexing of each plot. So now I'm going for the second plot. That's axis of 1. In that I'm going to apply the plot again. So plot of x data as usual and data. Yes, that's it. But this is a logarithmic representation. This is a normal representation. So you got both the data, both the pictures. So the scale sets the mapping from data values to spacing along the x-axis. So this happens in both directions and gets combined into a transform, which is the way that matplotlib maps from data coordinates to axis, figure or screen coordinates.